I'm Anil Kumar, and here is an exercise for you on real numbers. The question is, classify the following real numbers as rational numbers and irrational numbers. So what I will do here is I'll write down few numbers. You need to identify and explain whether they are rational or irrational numbers. So let me begin by saying, let's say 2 over 5, and we could say 3 over, let us say 7. Square root of, let's say 25, square root of 20. Let's say we have these four numbers for us. We can take some decimal numbers also. Let's write down 2.33 and that 3 repeats, or we could have some number which is non-repeating decimal number. So we could just write a number 1.41235567, something like this, where there is no pattern of repeating, right? So in that case, you have these set of numbers. Now your exercise is to write them as rational and irrational numbers, right? So let's make two groups, one group for rational numbers and the other for irrational. You can actually pause the video and place them in their corresponding groups. The first one here is 2 over 5. If I write it as a decimal number, what do I get? 2 divided by 5 is equals to, in decimals, 0.4. Since 2 divided by 5 is equals to 0.4, it could be written as a decimal number, so it is a rational number. How about 3 over 7? 3 divided by 7 is equals to, in decimals, a repeating pattern. So we have a repeating pattern here. So we have 3 over 7. Since it is a repeating pattern, it is also a rational number. So it is 0.428571, and everything repeats. Well, if you could write a number as a fraction, then it is always a rational number. Is that okay? So that is what it is. Square root of 25. Let's do square root of 25. It is, as you know, equals to 5. Square root of 25 is 5. So that is a natural number. It is, again, a rational number, because rational numbers include natural numbers also. How about square root of 20? So square root of 20 is equal to, in decimals, a non-repeating number. So that goes into this category of irrational numbers. So square root of 20 is equals to 4.472135 and something. Since there is no repeating pattern here, it is called irrational number. 2.33 could be written as 2.3 with repeating 3 decimal numbers. Therefore, it is a rational number, right? Now, this could be written as a fraction. So, as an exercise, I would like you to write 2.3 recurring as a fraction in this fashion. Okay, so try it out. There are videos, I'll give you a link for them, where I'll teach you how to write repeating decimals as fractions or rational numbers. Okay. Now this last number here has no pattern in decimal numbers, so that is an irrational number. So I'll write 4, 1, 2, 3, 5, 5, 6, 7 and some decimals like that as a number which is irrational number. Okay, so most of the time you'll be dealing with irrational numbers with square roots. So whenever you have a square root, for example, square root of 49 is 7, so that becomes a rational number. But if I write 48, then square root of 48 will not show any repeating pattern. So square root of 48 for us in decimals is 6.928. There is no repeating pattern. So that becomes a rational number, right? So that is how you could classify the numbers as rational or irrational. Remember, all these numbers are all real numbers, correct? So that is important. Rational numbers and irrational numbers make up real numbers. I hope that helps. Thank you.